Well, hello, good afternoon, good morning, good evening, wherever you're joining me. Welcome to today's DS&D coding session brought to you by Hamwe. This will be the first for the HDSC Winter 2023 cohort. That's for the data science and data engineering track. My name is Ajulo Christian. I'm the assistant programs coordinator at Hamwe and also a data scientist. Thank you very much for joining us again. Okay, for today's session, we'll be dealing on machine learning, regression, modeling. So those on YouTube and also on Zoom, thank you for joining. Without wasting much of our time, let's just dive right into the code. So I'll share my screen in a few moments. Okay, I believe everyone can see my screen now. If you can just drop it in the chat. Okay, cool. Okay, lovely. Right. We'll be handling like already announced on Slack, machine learning regression problem. We're dealing with a data set gotten from medical cost personal data sets on cargo. Talks about insurance companies and whatnot. Overview of what we'll be doing. So insurance companies need to set the insurance premiums following the population trends, despite having limited information about the insured population. So if they have to put themselves in a position to make profits, this makes it necessary to estimate the average medical care expenses based on trends in the population segments, such as smokers, drivers, etc. So what the problem we have to do will be medical insurance forecast or prediction. So to implement this regression project example, we make use of this data set gotten from medical cost personal data set on cargo. The aim here would be to predict the medical costs billed by the health insurance on an individual, given some or all of the independent variables of the data sets. Since the cost to be predicted is a continuous variable, okay, let me just explain that in machine learning regression, you are predicting a continuous variable that's like an amount, price for a house, price, the cost of medical bill, the price of an item, the billing of this. So regression modeling or regression analysis tends to deal with predicting a continuous variable. So it's pretty natural that regressions to be applied in this problem we're solving. So we could use different types of regression like polynomial, multilinear regression, or even elastic net regression. So enough of all the talk, let's just dive straight into what we have for today. So first of all, we'll be loading our libraries, pandas, not PC, Boma, Polyb, and rest. Then we'll be loading the data set. I already loaded this data set from cargo, so it's in my drive, my collab. So to load it, you know, it's pd.read CSV, then the location of your notebook and the data set. So it's going to load that. Then to view data sets. So this data set, I'm viewing everything. It has 1,300 rows and 7 columns. So the columns are the age, sex, BMI, the children, the smoker, the region, and the charges. So I'm predicting the charges as the medical insurance forecast as the amount that would be to their clients relating to this particular data they have of the clients. So let's get some info about the data. I mind you have written this code previously, so to save time, we'll just be explaining as we progress. Okay, checking the missing data. In this our data set, it is pretty clean. It doesn't have any missing data, so we don't have to worry about handling missing data. So mind you, if the data set you're working with have missing data, you need to handle the missing data by dropping it or filling it up with the main median or mode. That is if it's a category. The categorical data type is the one that's missing. So there are different ways of handling missing data. So just run some few analysis there to see if my network is unstable. Okay. Okay, describe this to show you the mean, the count, the standard deviation, and all that. Then df.head. So if you notice this info of our data set, it shows us the data type as integer objects. So we have categorical and numerical data type. So the categorical data are these ones, that's the sex, the smoker yes or no, the region, the numerical data, which is the integers, are these numbers. So I just want to check the number of unique variables in this region, that's this region column. So let's see, since you can view the entire data set. So we have southwest, southeast, northwest, northeast. Then also let's check the unique variables in others. So for the sex, we have female, male, obviously. And smoker, yes or no. So doing some processing, since our data type has objects and categories, so we have to pre-process it, because running it into the algorithm, it only works with numbers. It cannot pass a categorical data type to the machine learning model. So we have to pre-process this. So what this code is doing is to select which of the columns are objects and category, that's the numerical and categorical columns. So it brought it out. Then I want to print the ones that are numerical columns. They have that. So I'm going to pre-process it using label encoder. There's label encoding, there's one hot encoding. They are basically the same thing, but why I prefer label encoder is because there's another way you can do called the get dummies in pandas. That will create, it separates different columns for each of the variable in that particular data set. So, but I prefer label encoder because it does not create an additional column. It will just the same amount of columns, but it will encode it to numbers. So that's what this code is doing. From sklearn processing, importing label encoder. Then from label encoder, I'm going to hit transform the categorical columns. If you notice, it has changed to numbers. So this region changed to numbers 3, 2, 2, 1, 1, and everything. It encoded it to numerical data. So if you check the unique, like the previous time, we checked the number of unique data. So it was for sex, it was male and female. So okay, let's confirm. Okay, female and male. So the female, it was represented as 0, male 1, smoker yes or no, yes 1, no 0. Then northwest, northeast, southwest, southeast, 3 to 1. So with that, we just process the data to numbers. So with this processed data, we can pass it into the machine learning algorithm. So going to our modeling, I just want to check the correlation, that the columns are more correlated. So this is what this is doing. So from here, we see this smoker region is more correlated than the others. So this will be a major game player in our model. So this smoker column is an important part of our model. When we move on, you understand. So this next code is going to, what I'm going to use, there are several machine learning regression algorithms. So there's the linear regression, there's random forest, cat boost, gradient boost, decision tree. So what I'm just going to do, instead of trying to select different estimators that are best, I just want to call all of them. pass it to a pipeline and see which one works best. That's just the way I like doing it. So, but once you do your research, you know a particular estimator that is good for your particular data set, the amount of data sets you have and all that. There's a map on the scikit-learn library documentation that can tell you which particular estimator you can use for a particular problem and the amount of data sets you have. So you can go back to the scikit-learn library documentation to understand better. So I'm going to install the CatBoost regressor. Click install CatBoost. Okay, that's good. Then importing the estimators, also the train test split and our metrics, the mean absolute error, mean squared error, and the error to score. Okay. So then splitting the data into X and Y, I'm going to drop, our target data is the charges column. So what this does, the X data will be the full data set without the charges column. Then my Y data will be just the charges column, which is my target variable. So splitting it into X and Y. And there's this code in scikit-learn library, train test splits that's imported here. What it does is split your data into a training and testing data. Then you pass the test size if it's 20% or 30%. That's what this test size is there. Then random states, this is for returning the same variable every time I record this code. So instead of, if I didn't put a random state, if I run this, it will give me a different set of answers later on. So I choose a random state 42 here. So I'm splitting it into S train, S test, Y train, Y test. So checking the shape. So we see our data is already split 20% test size. So what this code is doing, I'm passing it to a pipeline. I just want to avoid running the code over and over again for different estimator. So I'm putting this in a dictionary models. All the models are imported. The SVR, the bridge, random regressor, SGB, decision tree regressor, and all. Then I'm creating a function called a fit and score. This will pass my S train, S test, Y train, Y test into this fit and score whenever I call it, since I already have my S train, S test, Y train, Y test splitted. Then passing the random seed. Then this will provide the dictionary of the model scores. Then what this code is doing is to fit the data S train and Y train, then it will score it. And mind you, in regression modeling, the default scoring is the R2 score, that's the R square, which is the R2 score. For classification problem, the default modeling score is the accuracy score. So let me just run this pipeline. I just created this code. Voila. Then calling this function I created, load and score, fit and score. So it will fit and score all my data with all the estimators I passed into it. So what this is doing, this is just providing, this is a CatBoost, showing how what is learning and all that. So from what I just passed, the HDBoost regressor tends to perform better. That's the R2 score. And mind you, the other ways to test the metrics of your model. So it does not necessarily mean the R2 score is best. Sometimes maybe the mean absolute error, the root mean squared error, or root mean squared log error. So with this, SGBoost did well, SVR didn't perform well, Ridge regressor did perform well. So to put this in a visualization, so we'll see it better as the R2 score. So from this visual, you notice that this HDBoost regressor performed better than the rest. Also, the random forest and CatBoost did better. So these estimators are there in the scikit-learn documentation. You can go back and do a review to understand better. Okay, so moving on, I'm going to select the HDBoost regressor because it performed better. So calling it again. So with this, I just passed everything to a pipeline. Instead of me testing each of my estimators, that will waste time. So as I pass it to a pipeline, I discover that my SG boost perform better. So with this, I can now select the SG boost regressor here. Then check the score, 0.87 score. Then I'm going to make my predictions called ypreds, then dot predict. We are predicting the S test, predicting the test data since we already split it to S test and Y test. So this brought out predictions. These are the predictions it brought out of the insurance charges. So this is too much. Let me just call the first 10 variables. So the first 10 variables, these are numbers in our model. So our model just made predictions. So moving on, I'll perform metrics to check if the model is performing better or not. So that now brings us to our model evaluation matrix. So let me just give a brief explanation of the metrics here. The R2 score, R squared, pronounced as R squared, or coefficient of determination. It compares your model's prediction to the mean of the targets. Values can range from negative infinity, which is very poor, to 1. For example, if all your model does is predict the mean of the targets, that's the target variable, its R2 value will be 0, which is poor. And if your model perfectly predicts a range of numbers, this value would be 1. So the range is from 0 to 1. So if you have a value closer to 1, it's better. But if it's closer to 0, the model is not performing better with that matrix. So you can try to use on that metric, which is the mean absolute error, which is the average of the absolute differences between predictions and actual values. It gives you an idea of how wrong your predictions were. Then the mean squared error is the average squared differences between predictions and actual values. So squaring the errors removes negative errors. It also amplifies the outliers, that's samples which have larger errors compared to others. So enough talk, let's just dive into the code to see and understand what I'm talking about. So checking the mean squared error, we're gonna pass it to the Y test and our predictions. Our mean squared error is this, then checking the root mean squared error, we have 4328. So that didn't perform better. So let's try the mean absolute error, which is the absolute difference between predictions and the actual values. So I'll be working with the mean absolute error here. It gives you an idea of how wrong your predictions were from the actual values. So our model achieves a mean absolute error of 2412.76. So on average, our model's predictions are 2412 units away from the actual value. So let me put it in a visual format so you understand better what I'm trying to say. So I created the dictionary, a data frame. So these are the actual values, that's the actual charges in a data set. These are what our model predicted. It predicted for this first one that was 9,095, the actual value predicted 10,000, which is not actually far from it. And the actual value was 5,272, predicted 5,923. So it's not actually that bad, our base model. So to improve the performance of your model, that's what we call the hyperparameter tuning. We'll not be doing this in this coding session. We're doing it in our next coding session. That's when I'm treating classification problems. So, but to improve your model better, there are options called the hyperparameter tuning, or you can add more data to your data set, or you tune the hyperparameters to see if your model will perform better or not. Therefore, this our base model. It's kind of like performing not bad in performance. So if you see the differences are not large. So putting it in a more visual format, if you notice in this visual, this will explain better. The actual values are the blue, the predictions are the red. So if you notice, the predictions are not that far away from the actual values. So they are like, this model is quite good. So if you tend to tune it forward, you have a good model that you can pass on later to external data. So let's check our feature importance, the feature importance of our model that's making it predict these values. So putting it in a visual format, I'm going to create a function that will plot the feature importances. of our model to see which of the feature is affecting the model more on how it's making its predictions. So I'm just going to run this code. Then let's plot it. So mind this session is going to be short. For those just joining, you can always check this video on our YouTube channel. It's live there. Okay, so from our model with the data set, if you notice, the most important feature is this smoker column, if the client is a smoker or not from our data set, which is yes or no. So the list was the sex, if it was the male or female, it doesn't really necessarily affect it. So the major feature that's affecting our model making this prediction is this smoker column. And if you notice from our heat map of our correlated data going back, you notice this smoker column is more correlated than the others. So the age and sex is not that correlated, 0.05. So that's why once you do your correlation and the rest, you see the features that are important that you can pass it to your model, that's to the estimator for the algorithm. So basically, it's just a brief run through of a machine learning regression modeling. And mind you, the difference between regression and classification. Classification, you are trying to predict this from disaster. For example, if a person has a disease or not, if a person has a diabetic or not, if this customer would subscribe to this bank product or not. So that's a classification problem. But for regression problem, you are trying to predict numbers, numerical numbers. If a medical insurance, like as we're doing, charges that the insurance company will charge the client or pay to the client, then checking the prices of houses, prices of cars, and whatnot. So that numerical data, that's the difference between regression and classification problem. So with that, we've come to the end of this short session. I believe you've gotten a grasp of how to do a machine learning regression modeling. And mind you, this session didn't dive into hyperparameter tuning to improve the model. And after that, once you've gotten a better model, you can save it using Pico or JobLib to save it. Then you can pass it on to, you can save the model, then pass it on to a foreign data set. So if this model is predicting well for insurance data, so for example, you have the clients as an insurance companies. If your model is good and the company gives you a task to, like, okay, I want to predict how we charge the client due to some data we got from a data set. So basically, if you improve this model and you save it, you can pass it on to a foreign data set with this particular data in data set. So you see if your model is predicting good or not. So those are the end-to-end of machine learning modeling. So if you have any question, let's just drop it in the chat. Those are on YouTube and also on Zoom here. Just drop your question. If you have any question, drop it in the chat and I'll attend to it. Okay, for those just joining, asking about if you, this video is live on our YouTube, you can always go back to the YouTube channel and view back if you didn't grasp everything. Okay, can we get the link to the notebook? I'm not making any promises. I'm not sure about that. If it will be shared, it will be announced in the Slack channel. But you can always go back to this video on the YouTube channel to get a grasping of it. And the link to the data set and also the CSV files will be provided in the Slack channel. So you have it there. Okay, any other question? Let me stop sharing my screen for now. Any other question, just drop it in the chat. Have like 5 minutes for questions. So I believe everybody got a good understanding of the concepts of what I just explained. So those asking for the notebook, if it will be made available, you would see the announcement on the Slack channel. It will be posted in the Slack channel. So, but the video resource is always available on our YouTube channel, the Hammer YouTube channel, so you can subscribe to see whenever it's posted. But after the session, it's there live on our YouTube channel. Okay, one more question before we call it a day. One more question before we call it a day. And also for this stage B, this session is geared towards the data science and data engineering track. For the stage B, just like you did for your stage A, you have a tag along project you're also supposed to submit at the end of the quiz. These are the answers to some of the questions in the quiz. So submit a tag along code, do the quiz and all that. And also this stage runs through with the premier project phase. Like already mentioned in the Slack channel, after the end of stage B, there's a break for you to still concentrate better in your premier project before stage C comments. So just help yourself with some time management and know how to organize yourself in tackling the course material and also your premier projects with your group. And mind you, only active participants in the premier project will be moving on to stage D. So if you are not active in your group, like an active participant, you contributed actively to the project, you'll be moving on. But if you don't participate actively, you won't be moving on to stage D. A form and every item will pass on to the project leads, which will tell and give a report of which particular intern participated or not. So do where to participate so you move on to the next stage and get more knowledge. So that's just it. Okay, there's this last question here before calling it a day. Can you go over changing of the categorical columns using the method you used? Okay, I think I have to share my screen again for this question. One last time. Like I did label encoding. So I believe you can see my screen now. Okay, it's loading. Okay, cool. So the label encoder, what I did here, let me go back to the code. In my data set, from the info of my data set, we have categorical data, which is numerical, and the categorical data, excuse me, and the numerical data. Categorical data are the ones that are anonymous, which is this sex, smoker, region, and rest. So I did label encoding. What this code is doing is to separate and tell me which of the column is categorical and which of them is numerical. So I passed on what we call the label encoder. Is a processing library in scikit-learn. So what it does is encode targets, if you can see my screen, it encodes target label with value between 0 and number of classes. That was why I first of all checked the unique variables in this column. So the unique variables in the sex was female and male. For this was yes and no. For the region column, it was 4. So after passing the label encoder, there's something called the one encoder. It is the sorry about that. I think I just had a network glitch. Okay, to answer your question, label encoding or one-not encoding, personally, it doesn't have like a lot of drawbacks, like you said, but you tend to work with your specific data, what you have in your data set. Why I choose label encoding? Because my data sets, in the data, it has unique variables. Like for the region column, it has northeast, northwest, north south, and southwest. That's 4 unique variables. So I try to use label encoding because instead of using a one-hot encoding, which is pd.get dummies or the other type, that will create an extra columns. I don't actually like that. I just prefer to use label encoding. Both of them are cool or good. So you need to understand your data sets first. So before you determine which one to use. So the next question, I have time for 2 more questions if I call it today. For the next question, what metric did you use to determine the best model to use? Was it R2 score? Yes. For this regression modeling, R2 score is the default metric score for model. So my default metric score was the R2 score. So that's why I went with the HDBoost regressor. I used the default score, which is the R2 score. Then if you notice, after which I also used other metrics, which is the mean absolute error that I used. I noticed that my model wasn't performing that bad. But you can see improve it by doing what we call hyperparameters tuning. We will not be covering that in this session. We'll be covering that in the next session. So that was the metrics I used. Hope I've answered your question. Okay. Any other question? Okay, in the absence of no further question, I believe everyone had a good understanding of what we did today. We still don't have a good grasp of it. You can always go back to our YouTube channel and go back to the videos. You get a good understanding of it. Okay, thank you very much for joining me to this session. This is where we'll draw the curtain for today. My name remains Julio Christian. I'm the Assistant Programs Coordinator and Data Scientist at Hamley. See you next time. Have a lovely day.